by using two pointer approach, that is valid palindrome. First of all, pause the video and read the question what it is saying. Then I will explain the question. So it is not only saying to check the string is palindrome or not. What it is saying? A phrase is palindrome if converting all uppercase letter into lowercase. This is one point. Removing all non-alphanumeric characters. This is the second point. And it's read same forward and backward. This is our palindrome. From this example, we will understand. Here it is given. Now, this is our string. Converting all uppercase into lowercase. First of all, we have to convert this into lowercase. The sentence has been converted into lowercase. Now, removing all non-alphanumeric characters. What are the alphanumeric characters here? You can see this comma, and this colon. And this space also. We'll remove this one too. A read the sentence in backward direction, you will get the same sentence, right? So this will be going to be a valid palindrome. Example, race a car, race a car. It's remove all these spaces. If we read it forward and backward, it is not same. That's why we are returning false. And one more thing here it is given. If it is a empty string, this will be also going to consider as valid palindrome. Normally, how a beginner will think. We will take an example like race a car. How a normal beginner will think. First of all, change this string to character array. The next step will be remove all special character. Then convert all the alphabet into lowercase. Then do the reverse. Compare with this main array. If it is equal, then return true. If it is not equal, then return false. That will be a normal approach for this question. And this approach will definitely work. But what will be the time complexity? We go up and we are iterating from the first element to last element to reverse the array, and the space complexity will be we go up n. Because we don't know what will be the size of an array which we will create to compare. Can we do better? Yes. First, the question is saying compare the both and palindrome. These signs are there in this question. So we immediately think this will be going to solve by two pointers. If you think carefully, we don't have to remove anything. We will just start with the left and the right. And we compare the left and right. Ignore the cases. If match, then we will move inward. Like left will move inside, right also move inside. If it is not match, we can directly say this is not a palindrome. We can directly return the false. If it will match, we will check with the next element. And as for the question, the things we have to skip. We'll skip the space. We'll skip any special character. From here, we conclude that we don't have to remove anything. We simply ignore the unnecessary character while moving. What are the possible cases can be generated here? If the left side element is not letter or digit, then we'll just skip. We'll just move left plus will do. Case 2, if the right will not a letter or digit, what we will do? We will do right minus because it is coming inward. Case 3, if both are valid character, left also and right, both are, then what we will do? Left plus right minus. we will compare the next elements. And one more here, if it is same, then we are doing this. If it is not same, directly we can return false. Let's visualize the solution with this example for the two pointer approach. So for this sentence, we will declare a left pointer here in the beginning and a right pointer in the end. Now we will compare both the character. We are ignoring the cases. You have to remember that. A and A. Both are same. What we have to do? L plus plus R minus minus. We will do L plus plus and R minus minus to move inward. So the next L will be here in the space. The right will be here. Now because of L is in a invalid character. Invalid character means non-alphanumeric character. Then we will only increase the L, like L only move inward. So L will become here again. We have already discussed, if either left or right they didn't get any valid character, they have to move. So here left didn't get any valid character, so it moved. Here L is here, then R will be in the same place. Then we will compare the character. M and M. Both are same. Again L plus plus R minus minus. And eventually the pointer will cross each other. There we have to stop. And we know for that we have that condition which we used to follow for the two pointer approach. The loop will be continue while left is less than right. Let's jump to the Java solution. First of all, we have to declare the left and right pointer. Left equal to 0 and right will start from the end. S dot length minus 1. The next step for two pointer approach is what? We will declare the loop while left less than right. Okay, here you have to understand something, like assume that we are having a string. Here we are having the special characters, semicolon, colon, space, star, and a letter. From the right side also we are having the same. Here will be our left pointer. What is our main motive? To skip this element. Okay, so to skip this element, instead of skipping one by one, we can just start a loop and we will move forward until finding a valid character. Right, here is the left pointer. Then we will start the loop from this current position until we find a valid character. So the loop will goes from here to the right pointer. Right pointer also will do the same. So whenever it will find a character, the left pointer will point to that character, and whenever the right pointer will get any valid character, it will point to that character. Now we can directly compare both and we can see whether both are same or not. Instead of comparing one by one, we can write the loop here, so we'll get a better visualization. We are going to skip the invalid character, right? This is our motive. So first of all, the first condition will be, it should be left less than right. Then the next condition should be to check whether alphanumeric character or not. So there is a function called characters dot is letter or digit. Here we will pass our left pointer value s dot at left. Whenever the character is not a alphanumeric character, we are going to skip that. Skipping means left plus plus. We are forwarding the pointer. Next, for right pointer, left is greater than right, and character dot is letter or digit. S dot char at right. Whenever we are finding any invalid character, we are just skipping. Left, skip down. Now we will skip the right pointer. So it skip all the invalid character. Now they will have one valid character. We have to compare them both. But before that, we have to convert them into lowercase character, right? So we'll declare a new value, a new variable for left character dot to lowercase s dot char at left. Then character right characters dot to lowercase s dot char at right. So we get the valid character. Now we'll compare them. If L is not equal to R, what does it means? This is not a palindrome. Directly we can return false. And if it is going like this, if the L and R left character and right character are same and going like this, we can just increment the left and decrement the right. So finally, if both the pointer cross each other without returning false, we will get the result that this is a palindrome and we can return true. So this is our code for the valid palindrome question. Now here the time complexity will be big O of n, because we are iterating each element for one time only. Left pointer also going up to n and right pointer also going up to n. If you are thinking we are having nested loop, so outside one loop is there, L is starting 1, sorry 0, R is starting, assume that 4. Inside another loop is there, L is incrementing. But here you have to notice something. We are not starting again with beginning. Like if L pointer has been changed here, if it is 3, then outside also it will be 3. We are not coming back from the 0 and starting again and again. And the space complexity will be big O of 1. We are not using any extra memory space. Try to solve this question. I will add the link in the description.